Except camera is doing a little bit of odd things. Let's see if I can fix that. I can't actually tell if that's that way, maybe this way. Oh, that's definitely worse. I don't want that. Back to this direction. Maybe. I'm just changing. I don't fully have the theory down about which of the green screen smoothness or similarity values, like what exactly they're doing to cause that. Okay, I think that's greatly reduced. Oh, now I have sparklies here. Or rather, here. Let's see if I can bring that down. Okay, let's try that. That should look significantly better. And I want to turn you to dark mode. Okay, so perfect, got that. Let's switch over and go to GitHub and check out the learning Rust thing. All right, so we're currently at extracting logic from main. And this is our code that we have still. Oh, we need to close this and reopen. That's the other problem. So what is it? It's going to be chapter 12 minigrep. With here's our code here. I don't know why this is green. Is it because unused variable error? But I'm returning. Oh, okay, I see what it is. It's because I'm not actually caring about this. I wonder if it would be happier if I use like underscore then, as an indication that it's like, yeah, it's whatever. Yeah, it is actually. It is happier with that. It's nice that it turned the file green so I can easily find like where specific errors are, and the green errors are not, they're warnings. They're not quite as bad as red errors. Okay, so there's still some. I think the light is just not as consistent today, I'm guessing. I will be right back. I want to go open up some windows and then we'll get started in about 1 minute. All right, I am back. Let's get the day started. Today I'm a little bit more tired than usual. I didn't get as much. I'm guessing it's because I didn't get as much sleep last night, but it's also Friday, the end of the week. Good morning, Miguel. So let's think about well, actually, do we even need to think about it? The last time, what had we done? We had extracted, we created a run function and putting it into the library to get everything out of main. So I think now we're just continuing on reading here. Now that we've finished refactoring the configuration parsing, let's turn to the program's logic. As we stated in separation of concerns for binary projects, we'll extract a function named run that will hold all the logic currently in the main function that isn't involved with setting up configuration or handling errors. When we're done, main will be concise and easy to verify by inspection, and we'll be able to write tests for all the other logic. Listing 1211 shows the extracted run function. For now, we're just making the small incremental improvement of extracting the function. We're still defining the function in source main rs. So the big thing is that they call run config. We put on error handling on our run, and it doesn't look like they have yet. They just created this run and put it here. The run function now contains all the remaining logic from main. Starting from reading the file, the run function takes the config instance as an argument, returning errors from the run function. With the remaining program logic separated into the run function, we can improve the error handling as we did with config new in listing 12.9. Instead of allowing the program to panic by calling expect, the run function will turn a result TE when something goes wrong. This will let us further consolidate into main the logic run handling errors in a user-friendly way. Listing 12.12 shows the changes we need to make the signature and body of run. So, what's interesting is that they have box error. So I haven't seen box. Is that provided for us, or are we going to create some kind of type or structure or something else for that? I'm not really seeing. Let's see. We're just returning OK right here. There's no other lack of semicolons. There's a question mark here, so it's and right here. So it's taking those and just sending them on up. I wanted to have custom error messages, so that's the reason why I didn't do that with mine. We've made 3 significant changes here. First, we changed the return type of the run function to result return empty or box error. This function previously returned the unit type empty parentheses, and we keep that as the value returned in the OK case. For the error type, we use the trait object box error, and we've brought standard error into scope with a use statement at the top. We'll cover trait objects in chapter 17. For now, just know that box error means the function will return a type that implements the error trait, but we don't have to specify what particular type the return value will be. This gives us flexibility to return error values that may be different types in different error cases. So that actually would have been really useful when we were trying to do the return type in a main function before we started actually doing proper error messages. We were like, well, what type of error will it be? The functions with question mark already return a result, so putting your own errors on is pretty redundant. I think the main thing was I wanted to change the error message. and string, and make it a little bit more user friendly. But yeah, for the result in which an error message that I like is there, then definitely yes. Second, we remove the calls to expect in favor of question mark, as we talked about in chapter 9. Rather than panic on an error, we will return an error value from the current function for the caller to handle. Third, the run function now returns an OK value in the success case. We've declared the run function success type as, well, just empty parentheses in the signature, which means that we need to wrap the unit type value in the OK value. This OK syntax might look a little bit strange at first, but using parentheses like this is the idiomatic way to indicate that we're calling run for side effects only. It doesn't return a value we need. Noteworthy, box T also allocates T on the heap. The type, so like this box, oh, so like the error. It allocates error on a heap. Interesting. When you run this code, it will compile but display a warning. Unused config. Oh, warn unused. Is that because we they had put that on and we didn't put that on ourselves because we just used the test-driven development. Box is just a smart pointer. Ooh, I haven't gone over smart pointers yet. Rust tells us that our core code ignored the result value, and the result value might indicate that an error occurred, but we're not checking to see whether or not there was an error. And the compiler reminds us that we're probably meant to have some kind of error handling code here. Let's rectify that problem now. Handling errors returned from run in main. We'll check for errors and handle them using the technique similar to the one we used with config new in listing 1210, but with a slight difference. Okay, so we have file name, main. If let error e run config. So yeah, this oh, interesting that they're creating. Are they creating a new error, or error is a an enum, right? So they're creating an enum with the error in it from config if it exists. Print line application error e. That right there. Or are they extracting it? Rust docs give me 2 different boxes, so I wasn't sure. Oh, are there 2 different boxes with capital B? That'll be interesting once we actually truly run into that and need to use it. If we use if let. Oh, right, I forgot. I didn't notice the if let there. Rather than unwrap or else, to check whether or not run returns an error value and call process exit. If it does, the run function doesn't return a value that we want to unwrap in the same way that config new returns the config instance. Because run returns parentheses in the success case, we only care about detecting an error. So we don't need to unwrap or else to return the unwrapped value because it would only be parentheses. The bodies of the iflet and the unwrap or else functions are the same in both cases. We print the error and exit. The Rust docs could really use some work, especially in a third-party crashes or third-party creates. I know devs hate writing in docs, but especially bad from the Rust community. Well, yeah, and I think the other thing is, I think they're trying to automate a lot of the creation of those docs. But it would be nice, and maybe that's like that was something that I'm hoping that our learning wiki can sort of help with a little bit. It might sort of it doesn't solve the problem. It's really more of a band-aid. But then the real question is, should the docs be concise and open for beginners and have another set of docs for beginners that sort of like point to but explain? Or do we want docs that can handle both beginners and advanced? It's a very like traditional question that has to be answered. Splitting code into a library crate. Our minigrep project is looking good so far. Now we'll split the source main.rs file and put some code into the source lib.rs file so we can test it and have a source main.rs file with fewer responsibilities. Let's move all the code that isn't the main function from source main.rs to source lib.rs. So the run function definition, the relevant use statements, the definition of config new function definition. The contents of source lib.rs should have the signature shown in listing 1213. We've omitted the bodies of the functions for brevity. Note that this won't compile until we modify source main.rs in a listing after this one. So what's interesting to me is that they haven't created any modules yet. So the first thing we did was we created a module that we put this stuff in. But I'm wondering if maybe for like the primary logic that you're using, you don't write modules, or you save those for other files. I'm not exactly sure what the what this is. Yeah, we did have the mod talk yesterday. I'm just sort of curious of whether or not they're going to put theirs into a mod or not. We've made liberal use of the pub keyword on config, on its fields, and its new method, and on the run function. We now have a library crate that has a public API that we can test. Yeah, they need better docs on mods, and I'm pretty sure they do a bad job explaining it, so that's why you're confused on when to use it. Yeah, and it's probably going to be like, I'm going to use it and read other people's code and then just start following what everybody else is doing. But the question is, do I really understand? Will I really understand why that's what the community has adopted? I'm not sure that will be quite as easy. Now we need to bring the code we moved into source lib.rs into the scope of the binary crate in source main.rs as shown in listing 1214. So 1214. So we're just bringing in the external crate, and then use minigrep config. To bring the library crate into the binary crate, we use extern crate minigrep. Then we add a use minigrep config line to bring the config type into scope, and we prefix the run function with our crate name. Now all the functionality should be connected and should work. Run the program with cargo run and make sure everything works correctly. Whew, that was a lot of work, but we've set ourselves up for success in the future. Now it's much easier to handle errors, and we made the code more modular. Almost all of our code will be done in source lib.rs from here on out. Let's take advantage of this newfound modularity by doing something that would have been difficult with the old code, but is easy with the new code. We'll write some tests. Of course, we've written tests a long time ago. So we're finishing 12.3 and we're moving on to 12.4. Developing a library's functionality with test-driven development. I question their use of test-driven development here, because they've developed and then they're testing. Now that we've extracted the logic into source lib.rs and left the argument collecting and error handling in source main.rs, it's much easier to write tests for the core functionality of our code. We can call functions directly with various arguments to check return values without having to call our binary from the command line. Feel free to write some tests for the functionality in the config new and run functions on your own. In this section, we'll add the searching logic to the minigrep program by using the test-driven development process. This software development technique follows these steps. Okay, so they are adding new functionality using test-driven development. So that is actually TDD. Write a test that fails and run it to make sure it fails for the reason you expect. Write or modify just enough code to make the new test pass, or factor the code you just added or change to make sure the test continues to pass, and then repeat from step 1. So yeah, that's exactly the process that we used when we were writing everything in the library code to begin with. This process is just one of many ways to write software, but TDD can help drive code design as well. Writing a test before you write the code that makes the test pass helps to maintain high test coverage throughout the process. We'll test drive the implementation of the functionality that will actually do the searching for the query string in the file contents and produce a list of lines that match the query. We'll add this functionality in a function called search. They would have lost the user if they started with TDD, so they started writing code, and now, I understand why they did it. And I think that's the thing, is like this book was also attempting to like teach some programming itself, like just okay, and here's how programming works as well. So I totally understand what they were doing. I feel that the book may be trying to do two things instead of like one thing extremely well. I'm not completely sure, so I'm going to save my thoughts until like completely the end of the book before I give my review. Okay, so writing a failing test. Because we don't need them anymore, let's remove the print line statements from source librs and source main.rs that we use to check the program's behavior. Then in source librs, we'll add a test module with a test function, as we did in chapter 11. The test function specifies the behavior we want the search function to have. It will take a query and the text to search for the query in, and it will return only the lines from the text that contain the query. Listing 1215 shows this test. Won't compile yet. The book is for new programmers. The rest by example is for programmers that need a crash course. Oh, interesting. So I haven't really looked at the rest by example too much, just to sort of like reference to see specific things that I'm going to do. Okay, so where is their test they're doing here? So they have mod test, they use the super, so one result, they set the query as this, they set the contents. So they're actually, they create a little haiku for this. They're looking for duct, which is right here. And then assert equal, safe, fast, productive, the vector that comes from that. And also they run a function called search and query and contents. So, okay, I could see that, and we can start thinking about how we would implement this ourselves. So in the library, we have our module, which essentially, so they're not inside of a module, and so we wouldn't need to be either. So basically, this is just an extra name that we don't need, and that's why we had so much trouble naming it, because we didn't need to at all. So if we're in here, we have our config structure, we have our implementation of config, and we have our run function. We're also going to want to add a function for actually doing the search itself from the string, because we have the file content. We now want to put that into, we want to put our search, our query, and the content into a function, and then get just the line that that has that in it. So we can write a test for that ourselves. So let's come down here. Function. So it should search. Okay, so inside of here, we're going to want both our query. So let, and the other thing is that when we run it, inside of run, we have our config here, and we're going to pass our do we want to pass the config into the query itself? Probably not, because it doesn't need to know about the file name. So we have config.filename that we pass in. We might want to just pass in the config.query and then the file content. So let query equals, this is a string, so we're just gonna do the same thing. And what are we gonna call this? So it should search. We can do exactly the same thing that they're doing, or we could just do something like, let's just do what they're doing. It's easier for us. So duct, and then also we're gonna want the contents here. So let file, I guess we'll just call it content. Now the reason why I'm using string from here is because I believe that we're going to be getting that exactly from the file. Like they return an actual, we have an actual string. So I want to make sure I'm using the exact same types. So we have Rust. Okay, so that gives us our string here. And then finally, we want to now call the function and make sure that it's that it works here. So we would want to assert equal, and the first one, let's just call the function. So it's going to be grep search. Maybe we'll just call it search. We're going to pass in the query, and we're going to pass in the content. And on the other side here, we're going to just say, hey, we should have a, now they're saying a new vector that can then be changed into a string right here, because it's the productive has the duct in it. So I can see us getting like a string back, but I could also see us, like they're suggesting that we get a vector of these 3 words right here. Looks like it's going to be split on, oh no, it's, look at that, it's a vector of that entire string. Okay, because if we had more things, if we had like this plus this, then we would get these 2. So we'd have 2 vectors. Got it. So it's going to be a vec of, should it be a string that we get ownership with, or should it be a slice? Well, if we're handing over to this function, we're giving ownership to it, then we can't get the slice back because it'll be deallocated from memory. So we'll have to get a string back from 2. Which will be this. Okay, so that should handle our search. Of course, search is not running, but we should be able to run this test and see it fail now. So cargo test. Not found in grep search. So perfect. Let's go create that. So it doesn't need to be public anymore, does it? Because run is going to use it. So I feel stupid. I was looking at that test wondering how it would pass because I couldn't find duct. Oh yeah, because it wasn't like a word on its own. Yeah, that's why we need the grep to do that for us. Okay, so we're going to just create a private function named search. That's what we called it here, right? Yeah. And you're going to take in what? You're going to take in the query and the content. So query, what type are you? You are a string, and content, you are also a string. And what are you going to return? You're going to return a string. Nope, you're going to return a vector of string. Okay, so we do that. And now we get other errors, which is like, hey, expected us to actually return said vector. So I could cheat here, and I could say, okay, we're going to return a vec of string from hello world, because that will make the errors go away, but it will, our test should still fail here because it'll say search is private. Oh, so our test can't do it without a public search. For some reason that makes me feel sad, but okay, so we have all these unused variables, and that's fine. But the big thing here is it should search as failed. On the left, it looks for a vector of hello world, and on the right, it looks for, of course, the entire sentence. So they're not equal. So let's go ahead and change this here. What we need to do is search, like actually search through it. And I believe that we can first break this string into vectors based upon the new line character that is at the end but is hidden. So I think what we can do is let's lines. This is going to be a type vec with do that. Is going to equal our content dot split based upon, now is it going to be a string slash new line? I think it is, dot collect. That. So I believe that this is gonna like, well, do that here. I want to actually return lines, as it were, because that should be a vector of strings. Mismatch types, expected struct standard string found reference to string. Never mind, so I got a reference to actual strings. So maybe what would be better is to instead, I got a reference to strings, so that should be 3 lines in there. And I want to maybe iterate through, and then for each one, test to see if that is in there. Okay, so let's also create a result equals, and we're gonna initialize a new vec, vec new, like that. Of course, it doesn't know what's going to go into it, but we're about to just drop things in ourselves. We'll push them in. Then we want to iterate through lines. So I guess it's not lines, it's going to be for, do I need the index? I don't think so, because I wanted to then copy it and like convert it into a new string. So in this case, let lines, let result for, is it just going to be line in lines dot iter? And so now we have a we have one of the strings, the strs at a time. And so I'm sure, let's see, line dot, I was hoping it would give me a list of potential things, because like, there search, no, it's It's now just VS Code guessing for me. So I could print line and sort of see what this is, which is going to be line. But in the end, we need to return out of here this this vec again. So vec just like that. Let's save that. Okay, so result equals vec new. Type annotations needed. So you are going to be vec string. I think you can also be a string here. So we're going to tell what we're planning on getting from here. All right, so let's run this and see what we got. The trait bound standard iterator from iterator is not satisfied. Collection of type. So content.split.collect a collection of type standard vec standard string cannot be built from an iterator. Oh, is it because split is already turn it into a vector? Collection of type standard vec string cannot be built from an iterator over elements of type stir. Oh, is split okay, that's the problem. So maybe does split return an iterator, or I guess these are really going to be references to stirs. But we're going to run into problems with the future things making assumptions, I bet. Actually, I ran the test so that it worked. Okay, so it did get the S. What we're looking for is that print line. Did it happen? Here it is. Test, it should search standard out. Rust, safe, fast, productive. Pick 3. Oh, and we see the quotes over each one. So it did see each of these. So now we do need a way, some kind of way for us to search through the substrings. So line dot. Fortunately, we know that line is going to be just a stir. So let's go to the documentation and take a look at. Okay, we need. It's going to be a Rust documentation search stir. So if they have like a search or something else in there, search substring, here's my indexes. Oh, did I almost? Ugh. Yeah, it's whatever Firefox is like displaying on that main page. I guess I could change it to like the Rust main web page. Contains returns true if the given pattern matches a subslice of the string slice. Returns false if it does not. Basic usage, let bananas equals bananas, assert bananas, contains nana. Assert not. Okay, so contains, that's what we want. And it returns a Boolean. So in our 4 lines, so if line dot contains, it's plural. Yeah, personally, I've watched maybe the first episode of Westworld from the first season, and I just haven't gotten around to like watching any further, even though it is intriguing. But I'm really bad at watching like television or movies. Okay, so if line contains, and what are we passing in? A stir, so a reference string. So that would be our query here. And I guess at this point in time, It was shocked that my wife loved it. She's actually the one that's been moving us along. Oh, awesome. Let's see. I actually want this to be a reference to a stir. So if I just take in the content as references, I wonder if that just changes things around, and I can replace the substring because it's existing in run. I don't need to fully pass it in. She went out and bought this 1972 movie. I have seen that movie. I liked that one. That result vex. Okay. So let me think about this. We don't need to give ownership to search. Search can just give back the substring of the one that we need. That might be what it is. But if we do that, it'll need type annotations will be needed. I could create a copy of it, but like the lifetimes will have trouble if I like send one of those out. But for example, if in here in his test, I don't actually have string be a front. Well, so they're going to start as these strings. But if I pass in here, this is a reference to query and a reference to content, then I want, what do I want back? I want just a reference to these stirs. So I expect this to come back. Now in search, we have, okay, this is just going to be a stir. It's not, I guess it's not running the test automatically to tell me if it's running or failing. I need to deal with this on my own now. Okay, so we have our stirs that we're going to bring back. If we do make this a reference, it is going to need lifetimes, isn't it? Although it's just the content, so it might figure it out, but for the most part, it won't know which one this is. So I'll probably need to say like this is lifetime B, and I'm returning substring for lifetime B. But I'll get to that once it actually fully yells at me, because it's not doing that right now. Okay, so let lines equals vec reference to string content split, and then we collect. Result is a vector string, so a new string here. Do I need that? I'm not sure I really do. I think this should be of references, and what I'm really gonna do is push each line, like the reference to each line, inside of this result. So for line and lines iter, if line dot contains the query. So if this is truthy, we want to say we want to push the line into here. So result dot push line. Otherwise, we don't do anything at all. We just like continue on through. Then when we're done, we're going to return the result. All right, no red or green squigglies. Everything seems to be happy. Let's go ahead and test this. Missing lifetime specifier. So we do need to specify the lifetimes here. So public function, we need to give it A and B. Yeah, 2 input strings and 1 output string is impossible for the borrow checker. Yeah, if I remember correctly from what they were talking about, and then what you put in, Miguel, is the borrow checker is basically saying this will be A, this will be B. So I'll come in here, say this is A, this is B. And it will say, well, I need to make sure that this one, like which one this is. But in this case, I can say I am always going to be returning off of content, not off of query. So this can be the lifetime specifier for B. And I'm ignoring A, essentially. Expected identifier found. Where do I put it? Is it in here then? Maybe right there. Cannot borrow immutable local variable result as mutable. That result. Oh, I definitely need to make this mutable. I need to take time this weekend to oh yes, definitely. It's an awesome one. Okay, so our tests are passing now. All right, so let's try with a test that's a little bit more complex, because it's a search, but if we pass in for like 2 things in here, it should also work. So I'm going to copy this test and duplicate it. Okay, so test, it should search and find multiple. So that query is maybe, if we're going to do this same thing, is there anything that is, yeah, so it. What can I see here that's the same? Maybe I could just change this to like, hello. Hi there. Hi there. So just sort of playing with the language and making stupid stuff. But I want to search on hi, which really should get these 2 lines. So query is going to be hi. We're going to pass in the query and the references to the query and the content, and we expect to get back 2 vectors. The first is going to be, so at this point in time, I really think I should say that result equals, it's going to be a vec with 2 items in it. The first is going to be hi there, and hi there. And now I can check to make sure that these are equal. So it's going to be result like that. Since it's a reference to stir now, couldn't you get rid of them string from? Are you talking about in here? I could. The reason why I want to keep these in place is because this is letting me know that in the real function for run here, where is it? What we're getting is actual strings in the file open. Like we're getting full strings on a heap, as opposed to stirs. So I just want to like start with the same thing, even though it's different. Oh, I might update it tonight or tomorrow morning, make it a bit more concise. It's okay for now, but after rereading, well, don't beat yourself up. It's really awesome the way it is. But if you want to continue writing it, heck, if you want to make a normal blog post and like put that on Medium or something and then just link to it from there, that would also be, that would work too. Or any other blog source. I feel you should get a lot of credit for that. let's try this. Let's see if this works as well. Failures. Okay, so left, hi there, hi there. So I got this. The right was hi there, hi there. Wait, what? That's exactly. I missed the dot. I missed the dot. Yeah. There we go. Tests were broken. Now it works just fine. And finally, I want to test where absolutely nothing happens at all, and that should just be an empty array. So if I copy this one last time, test, it should search and find nothing. Let query equals string. So we can do the exact same thing here, but instead we're going to test goodbye. So it should not find this at all, which means result should be an empty vector. And there we go. Let's run this. Cannot infer type for T. Ooh, so we do need to tell it that this is going to be a type of vec reference distort. And perfect. So it passed. There was it successfully didn't find anything in my search. So now we can implement this in strings, which we'll do next time because it is 7:54 a.m. So let's go ahead, close this out, and for now, a proper blog post is my goal. Yeah, I know. Time flies so much these days, especially like when we're having fun, when we're coding, when we're learning stuff. It's all good. So let's take a look at our README and see where we are. So currently at what does a panic look like from a compiled app? Extracting logic from main. So we also, like the new thing of what we want to now continue doing is putting the search capabilities into the run function. Okay, we have that, and we're on a new section here, which is we're on the write a failing test, but we're specifically on this section, like right here. I guess we could, I'll just put this in right here. Oh, if we don't remember, we reread that one paragraph. That's not the worst thing in the world. So extracting logic from main, click on you, get the URL. All right, so pasting into there, save. So now we have a whole bunch of stuff to update, which is main, which basically is search function created, not yet added to the run function. And we'll push that on up to GitHub. So in the meantime, I will share this URL with the chat. So if you're watching right now, you want to go take a look at the code, or if you're watching the VOD, please take a look at the code here. I also have it linked to this repo in the stream description, and I'm archiving these videos over to YouTube and putting them in a playlist. All the links that you would possibly want are in the description there too. I was gonna say that you could find me on Twitter, and that's where I post like when I'm gonna stream. Of course, I forgot to do that today because I was running a little bit late, and I just sort of started the stream and just went off with it. So I completely forgot to advertise myself. Which means that if you want to always be notified when I'm going live, regardless of whether or not I remember to tweet out, follow me on Twitch here, or follow me on YouTube for my archived videos. With that, I don't think I have anything else, but we have 3 minutes left until 8 o'clock. So is there anything else we want to look at right now with this? People were chatting about Miguel's post. So what they were talking about was, in issues here on the Learning Rust channels, Miguel created a lifetimes post, which is a really awesome post about how lifetimes work. And this is a super great conversation, because at the bottom here, Jehagans3 replied with a really cool thing that you can do with lifetimes, which is assign essentially a type to a lifetime, which means that this is how you can say, well, okay, I want to assign each incoming parameter its own lifetime, but then only return 1, but have the compiler still understand what's going on. So Miguel said he was going to update his post with more information. But basically, it's a really awesome conversation, and I highly recommend anybody sort of take a look at it if they want to. I'm doing these, going through the book streams every single weekday at 7 a.m. Mountain Time. So yes, my next plan is to be back here on Monday, and then we'll be implementing that feature, the search feature, into the main function. And I'm guessing coming close, we're about halfway through this chapter, which is going to be building out this minigrep. So with that, everybody, thanks for stopping by, and I'll see you all next week. Have a great weekend. And we skipping Wednesday? Wait, Wednesday is 4th of July, isn't it? Probably. We probably are skipping Wednesday. I'll tweet out, because it's a weekday, I'll tweet out if we're skipping it, which most likely we are, but that way people can see that, and I'll just try to build that habit of always tweeting out when I'm not gonna be streaming on a weekday. All right, with that, it's time for me to head out and get ready for the rest of the day. So I hope that you all have a great day. I am now a ghost. I just realized that you can see the text through me and here. Sad European. I'm sorry. If I do any fireworks things, I'll think about you guys. But with that, I'm gonna head out. Hopefully next time I won't be a ghost in the camera, and we'll figure that stuff out. So with that, see you next time. Have a great weekend and a great day.